right, so for our 2017 potato problem, it got a lot of flack actually. If you were to Google 2017 AP Calculus memes, you'll see a whole bunch of funny stuff about potatoes and bananas. They had two food questions. No one would ever really use calculus, I don't think, in this day and age when we have the thermometer, right, to find the internal temperature of a potato. So that's why I got some flack. Could have been really about like finding time of death using the internal temperature of body. It's the same kind of, that would have been a much better problem than the potato. But in this problem, you're taking a boiled potato out of the pot and you're just letting it cool, and you can run some calculus on it. You measure its internal temperature to be 91 degrees at time 0. That's really important. Whenever you read a question and they give you a point on the graph, you're going to be using it probably multiple times. So off on the side, again, we haven't done many of these real FRQs in full slowly. So this is kind of a lot of learning goes on these days, but little homework. So I have the point 0, 91. But in this problem, they're not representing x comma y. They're representing t comma h. So I like to write that above it. So I'm kind of like, okay, t is actually the x I'm used to working with. H is actually the y I'm used to working with. All right. So then they tell you that the internal temperature of the potato is always greater than 27 degrees Celsius. What you are going to learn when you do Newton's law of cooling in Calc BC is that's actually probably the temperature of what we call the surrounding medium. Because you can't have something colder than it's the atmosphere in which it's in. Does that make sense? Like if I fall in the lake and my body starts to cool rapidly, I can't get colder than the temperature of the lake. So this is probably telling me that the temperature of the room was 27 degrees Celsius. But I probably need that for some part of a question, so I'd underline it. Then they give me this differential equation. All right, so in my head, I'm going, oh, I bet probably I'm going to need to be doing some separation of variables, but don't assume it's the first question or the second. You have to know when to do it. And actually, for this, you actually never end up separating this one. But in my head, I'm thinking, oh, I might have to. But when I read it, here's my point again, right here. The first one says write an equation for a tangent line. I was a reader for this one, and I had a lot of kids do a lot of work where they separated variables, they did natural log, they plugged in an initial condition, they did it beautifully, and they got 0 points, because that's not what you do for the equation of a tangent line. What have you been told you need? Always. A point, right, on the graph. So I'm going to draw a fake graph of h over here, and I always suggest you kind of do that. My fake graph of t going in, h going out, just draw a fake graph so you know that h and t, okay, I need a point on the curve. They gave me one. So I'm going to go put that down there because Carissa said I need a point. They gave me one. They gave me the point that at time 0, the temp of the potato, which they're calling H, I don't know why, maybe for hot potato, is 91 degrees. There's my point. What else have I told you always need to get an equation for a tangent line? The slope at that point, correct? Now, how do I find the slope at that point? Plug it in. Yeah, you need to understand that that's what a derivative is. It's the slope of the tangent line. So this first question, the national average was 1.54. That's kind of sad because this first question is, I think, is a free 2 points, and there's a free third one. So I think at a minimum, all of you guys should get a 3 on this one. Because the first part A, and then the separation part in part C is like kind of, there's a free point. All right, so here is my derivative at any given point, and I'm going to say at 0, 91. You don't need to write this down. This is me like saying, what do I need? I need to find the rate that the potato is cooling at this time, and this is what's different about this one. You're used to plugging in the x value, but this is a function of the h value. So I'm going to do 91 minus 27. You could leave that because it's an FRQ, and it's numerically correct. It's bothering me, though. And honestly, if it's an FRQ, usually the simplified number is nice. So when I subtract these, I get a 64, and negative a fourth of those is negative 16. Now, if this had said to find the slope of the tangent line and then label with correct units, you also need to know how you would label that. How would you label it? It didn't say to, but I like to kind of talk about sometimes what they'll say, including correct units, find the slope of the tangent line, or the rate that the potato's cooling. What would I label it in? Degrees per minute if it was minutes, or yeah, degrees Celsius. But it didn't have it. This was an equation of the tangent line, so I have to keep going. So you're taught that you do y minus the y you know is equal to the slope there times x minus the x I know. You would get the point for that. Yep.
For the FRQs when we grade them, do we have to have the D over like the DT like form?
No.
In there to give the point?
Nope. You can just have that. Okay? Also, they ask me questions like that because there's most of the AB ones I know exactly how they're graded. I've never graded for BC, so when they ask me questions, I always have to say, I think you get the point, but I don't know for sure. Right here, I know you would get the point for this one because I was a reader for it. They didn't like it when kids left it like this, but they're like, oh, they know what they're doing. They got it, the equation of the line. What do you think the panel who tells us how to grade said they didn't like about this answer, but give them the point? Yeah, this was a function where t was actually our x and h was actually our y, so it actually should have been maybe better written as the temperature of the potato is 91 minus 16 times the time going in. That means you really understand what's happening. It's at 91 and it's going down 16 degrees every minute. Does that make sense? The kid who writes it like this is memorizing point slope form of a line, but they might not quite get how it relates, but they gave it to me. On this one too, I'm not done because it says to find it 3 seconds into its cooling. So the temperature of my potato after 3 minutes, is 91 minus 16 times 3. If you are true to yourself and you know you struggle with arithmetic, leave it, right? Because the worst is if you go, 91 minus 48, 53. You write it down. Then you just lost yourself a point, right? So just leave it. But it actually ends up being 43 degrees. Understand what you just did, okay? You found the temperature of the potato away from the point of tangency. Like, it was actually at 0, whatever, but I'm just giving a general sketch. You hopped on the line, and you estimated that was up at 43 degrees. Does that make sense? And it's not that line, and it's not that function, but you're not on the function. That's your estimate. Part B. First of all, you need to know what this means to do, right? Doesn't mean to square everything. What does it mean to do? Take the second derivative. So this is where this one was so easy to read, because 99 out of 100 tests that would come by got 0 points on this one. I'm going to tell you why. They missed something. Understandably so, but they missed something. So I'm going to have you write the HDT equals. It was a negative 1/4. Can you remind me what this? Thank you. H minus 27. That is the first derivative. And last hour struggled with this too. And so then in their groups, there was lots of discussion about letter B on the bird one you're going to do. So I'm going to go over here and tell you what some of the groups said. I need you to explain what's going on again with that. So I'm going to do it right now. I'm going to go and make this dy dx, something you're more familiar with instead of the HDT, equaling negative 1/4 of, now look at what variable do you think I'm going to put right here? Y. Not like WH, the letter Y. Yeah, I thought, you said it kind of like a question. Why? All right, so Y minus 27. You're used to taking the derivative with respect to x. What is the derivative with respect to x of 1/4 x? It's 1/4. It's actually 1/4 dx dx. Right? What is the derivative with respect to x of 1/4 y? 1/4 dy dx. And that's what's going on here. And because College Board wants to make sure you don't just understand, like memorize things, like the derivative of any line is the constant in front of it, Yes, as long as there's a variable match there, right? If this was y equals mx plus b and it was negative 1/4 x, yes, negative 1/4 is the derivative. Do you see what I'm saying? Most kids did not catch that. This was almost everybody I was able to go 0, 0, 0. Then every once in a while I'd be like, ooh, someone got it. All right? People who got it almost always wrote it out. So they said, well, I need to do a second derivative of the first derivative. By the way, do you see that's why the notation is like that? Do you see the two D's and then the H and then the DT's? See what I mean? That's why they give that notation. If ever you wondered, why do they put the two in on that one? It's because they're next to each other. And why don't they on this one? It's because there's two. Does that make sense? Okay. So on this side, I'm actually going to do the derivative with respect to t. T is my variable of change. T is the new x. And that's of a negative 1/4 times h minus 27. Now watch. What's the derivative of any constant? 0. No matter what, constants don't change, so the rate of change is 0. So I don't really need to worry about the minus 27, or technically the plus 27/4, because that part is 0. Does that make sense? I need to know what the derivative of that is. Negative 1/4. What? Yes. Guess what? Pretty much everyone across the world wrote for that. It was like almost every test. The kids were like, oh, I know how to, it's going to pop back on in just a second. They wrote negative 1/4. And then it caused them to get the second part of the question wrong as well, right? So this is actually, oh, dang. Sorry, I bumped my board and now it's being finicky. All right, so negative 1/4 times dH dt. Do you know what dH dt is? Yes, right? So that's where it is a little bit tricky. This one, very few kids got. And there's always a piece of every RQ that very few kids can get. There's rarely nines. Like when you're grading, it's like, oh, a 6, a 5, a 4, a 0, a 0, a 0, a 1, a 2, a 3, a 4, a 5, a 9. Holy crap. So you should always be going, this is hard on one of them. That would have been this part. All right, here we go. So it's negative 1/4 of the negative 1/4 times h minus 27. I can just leave it like that if I want to. Am I done with the question? No. Because it says, was my answer in part A an under or an over estimate? Remember, I hopped on the tangent line and I used it to estimate a 43. I was off, right? I was either over or under. Do you guys remember how we decided whether it was over or under? We're going really slow. We're just doing a lot of learning today, not much practicing. The actual reverse of yesterday. Do you remember how I decide whether it's an over or an underestimate? Something's off with my... It's about concavity. It truly is. And concavity is about the what? Second derivative, there we go. And my second derivative is a negative 1/4 times a negative 1/4. It's a positive 1/16, correct? So let's go write that. It's a positive 1/16 times h minus 27. All right, so let's go write that. Good memory again, Bella. What's up with your memory lately? It's been good. She's got good memory. Good memory. That's good. It means it's sticking in there. All right, so 1/16 times h minus 27. What is it about the second derivative that'll tell you the concavity, that'll tell you whether we're under or over? Whether it's positive or negative. You might say, well, I don't know if this is positive or negative. I don't know what this is. Go read the stem of the problem. What did it say? H is always. It said it for a reason. Greater than what? 27. The potato's not going to drop below 27 degrees is what they're telling you. Correct? So this is greater than 0. Agreed? What does that mean my function was? Therefore, the function, you could call it h. A lot of kids will slip and call it y. That doesn't matter. So I mean, the kids in right after x, you still get the credit, right? H is concave up, like the cup. Some kids will go over here and go, okay, it's concave up, underestimate, and they'll just write underestimate with this picture. You don't get the point. So if you're going to use a picture to help you, you have to explain the picture in words. Are we learning? Right? So H is concave up. And what are you going to say? 43 is a what? Under or over? Yes. 43 is an underestimate. Some kids even really get it and they'll write, for concave up functions, the tangent lines always lie below the curve, therefore we're always under. That's fine, but that's a lot of words to read, right? That part was tricky. You get why? Again, almost everybody said that this second derivative is negative 1/4. So then they concluded concave down. So then they said, well, their tangent line is above, so 43 was an overestimate. And they thought that was easy, right? And you never get to see your test. So you'll think you got it right. You feel good about yourself. But most got it wrong. All right, so our next question is part C. This is just reiterating the initial stem of the problem. But for part C, they're saying, well, as if we didn't have enough fun finding the temperature of the potato with function H, we are still going to neglect to use our thermometer, and we are going to come up with a new function to find the internal temperature of the potato. So now we're done with H, so don't even look at H anymore. It says this, find an expression for G of T. So let's write what we're given. We're given the rate that G is changing over time is negative, and then it's a G minus 27 to the 2/3 power. And it says find G of T. What should that trigger when it says, we have to figure out, well, what's the upper, this is right now. This is what you did yesterday a bunch of times with y and x, correct? You need to solve for the upper variable. You need to undo the derivative. You need to integrate, but you can't do it until you separate. So there's what I said, there are 3 easy points. Part A, both of them, and the separation point for this one. Those are 3 freebies, I think. So let's do 1 over G minus 27, and that's to the 2/3 power, is equal to a negative, because I like to keep those constants on the right, the dt. That's an easy point, right, John? Like, just a separation. What do we do after we separate? We integrate. You can leave the negative in or pull it out. I can like to pull it out because it's a constant. Then your next points are for antiderivatives. The left is a little weird because there's nothing there, but it's really a 1. The derivative of what is 1 with respect to t? Well, x if it was dx, but t, yeah. So this is a negative t. By the way, if you put in x, you probably get credit. They call those spelling errors because actually in one of the countries, the x's look like t's. Or the t's look like x's. There's some country where they make their t's like this. Did you know that? I don't know what one it is, but it was pretty common. Right? So if you put an x there, you wouldn't lose that point. Next up, this is where a ton went wrong. This is u sub. I love that. Let's do it. You wouldn't have done it wrong, then. I don't think. It is u sub. I like that. U is always the inside function. If that doesn't work, it's the entire denominator, hoping to generate the numerator. If that doesn't work, it's an exponent. Inside function always first. I like that. All right, well then what's your du? Technically dg. 1. So your du is dg. So if Carissa sees u sub and she's going to do it, this is what she's got, correct? She's actually got 1 over u to the 2/3 and then exactly du. And she can write it off to the side because she's just using this to kind of help her. Because some kids do this part in their head. You don't get points for this. You just get a point for the antiderivative. However you get there. I went into u sub because she said it and it's so safe. Right? Now, how do I integrate this? Who said that? This is a power rule. What do you think a zillion kids across the world did right from here? ln. They call it the universal application of the natural log rule, which was whenever kids see a denominator, they're going to say it's ln. No, it's not. It's u sub, and if when you do your u sub, you end up getting the derivative over the original, then you can say it's natural log of u. Okay? This actually ended up being u to the negative 2/3 that you need to integrate. Some kids see it right from here. That's why they'll just go, well, that's g minus 27 to the negative 2/3. It doesn't, as long as you get there. So this would be add 1 to the power, divide by the power. Are we good? So this would be 3u to the 1/3 power. That was the tricky part on that one. Do you see what I mean? I'd say many kids, more went natural log than went power rule. All right, so from here, you have to decide, do you want to find a car rule or not? I think I will. If it's nice. This is what I mean by if it's nice. What did they say the temperature of the potato is? What did they say it was? 91, right? What is 91 minus 27? 64. Does that have a nice cube root? No, you're not. Right? What's the cube root of 64? It's 4. Yeah, that's a square root of 64. Right? So I think I'm going to find it right now. I would have the cube root of 64, which is 4. 3 times 4 is 12. 12 would have to equal 0 because it was times 0 that it was 91. So that wasn't hard for me. I always just try it right away, and if I'm like, yep, I can do it. If I'm like, don't really want to work with the natural log of 5/3, then I don't do it. All right, so I have 3 that I haven't dealt with. I have my g minus 27 to the 1/3 power. It's equal to negative t. Now we can start cruising, right? What's next? Divide by 3. I'm just going to erase it because this is the easy part. What's next? Somebody besides Carissa. What's next? Cube it, right? Not third word it, but cube it. What's next? Say it. What's next? Add 27. Am I done with the problem? I don't know. Read it. It says I'm supposed to figure out the temperature with this model at time 3, it said, right? So I'd have a negative 3 plus 12 over 3 quantity cubed plus 27. Should you then sit and calculate that out, or should you move on to question number 5? Move on, because if you do that wrong, what's going to happen? You're going to lose the answer point. But I'm going to do it because it's nice. This is a 9. 9 divided by 3 is 3. 3 cubed is 27, but if you accidentally call it 9, you just lost your answer point. Do you see why I say just leave it? This ends up being a 54-degree potato. The national average on that, 1.54. Okay? In groups, you're going to do the next one. The national average on that one was 2.57. We looked it up last hour. So the 2012 about the bird, right, 2.57. I told you to skip the next one, right? Press up. And your homework is the very last one on your own. So once your group is done, you can either just sit there and do it on your own or move away, but I want it to be totally me, and group, and then totally you. What do you think I want you to get out of 9 on that last one right now? Well, I want you to be over the national average. What's the national? I'm going to look that up. I forgot. So I'm going to go look that up while you guys are getting in your groups. We're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1s by Julia Aguilera. 2s back in the corner. 3s up here-ish. 4s back there-ish. 5s over here-ish. Make a pod. Get started on the bird. Collate together. And I will tell you the national average on the one you need to do on your own. I think it's going to be pretty high because I think it's going to be easy. It's way easier than the potato.